So hey everyone, this is the next class. I just told you that is a selection of base for active methylene compounds. Okay, so general structure for active methylene compound is you know that CH2. This is methylene group. Okay, and if there is an electron withdrawing group attached to this group, then this is called electron withdrawing group. Okay, so basically the electron withdrawing group, the example is CHO or COCH3. These are the electron withdrawing group. Okay, so here there are 4 example. These are active methylene group and the cyclic structure this and this. Okay, so these are very important for your exam point of view, the active methylene group. And in case of that is PGT JSSC, there are 6 to 7 questions. Okay, in 2000 I think 23 the paper is, so 6 to 7 questions from active methylene group. Okay, so this is the very important topic for your PGT exam. So basically hydrogen atoms that are between two carbonyl groups, okay, such as dicarbonyl compounds, have pKa values in the range of 9 to 11. Okay, so such alpha hydrogens are much more acidic than alpha hydrogens adjacent to the only one carbonyl group and which have pKa values 18 to 20. Okay, so this is pKa value. Okay, so the range, higher the range of pKa value, lower the value of pH. Okay, so or the acidic strength. Okay, so pKa and these are the values. Okay, so when active methylene groups are attached to this, the pKa value is larger. So therefore much weaker base such as NaOH, NaOMe, NaOET, that is methyl sodium methoxide or sodium hydroxide, can be used to form an enolate formation such active methylene compounds. Okay, so case 1, when both carbonyl groups are aldehyde or ketone, that is beta ketones, first oxybase, although oxybase are nucleophilic in nature, but since there is no good leaving group, so this will not attack on carbonyl carbon. Okay, so therefore they will act as a base and abstract alpha hydrogen atom. So this is the mechanism for this reaction. So here the base is used NaOH or sodium methoxide or sodium ethoxide. So basically these base are abstract alpha hydrogens and this is the enolate formation, and it is highly stable due to 2 C double bond O group carbonyl groups. Okay, so these are so highly stable that will not abstract proton from the base again. Okay, this is the resonance hybrid for this structure. Okay, next carbon base, this is never used for this formation. Next hydride and nitrogen base can be used easily. Okay, so next case 2, when one carbonyl group is aldehyde or ketone and another carbonyl group is ester. Okay, so this is very important active methylene compounds. Okay, so acetoacetic ester, ethyl acetoacetate, ethyl 3-oxo-butanoate, ethyl 3-oxo-butyrate. So these are very important for your exam point of view, and this is your example, and you have to remember all the structure, and from this structure the question is asked. An active methylene compound such as beta ketoester has 4 reactive centers. Okay, so these are the reactive centers, 4 reactive centers. And oxybases, use of NaOH, okay, sodium hydroxide, this is nucleophilic in nature, but there are 2 electrophilic centers. Okay, so attack at ketone group, carbonyl carbon of keto group is not feasible at there is no leaving group, and however attack and carbonyl carbon of ester group is feasible because OET, that is ethoxide, is a good leaving group. Okay, so here the attack on the ester carbonyl group, and because OET is a good leaving group. Okay, so basically beta keto acid is formed, but beta keto acids are highly acidic. Therefore NaOH cannot be used for beta keto ester for enolate ion formation. Okay, so here electrophilic addition is occur. Next, use of NaOH, sodium ethoxide. We have already studied that in case of esters, we must use same type of base or nucleophile. Thus, if you used sodium ethoxide, then it acts as a base and is abstract hydrogen, okay, from active methylene group, and the resonance structure is this. So complete enolate ion hair formation, because it is more stable, okay, rather the reaction is not placed. So we can use NaOR in case of esters, okay. So hydride and so nitrogen base can also be used for complete enolate ion formation. Note that OET, that is ethoxide, LDA, lithium aluminum hydride, sodium hydride, triethyl ammonia, these are considered strong base and are active methylene compounds, also have strong acidic hydrogen, alpha hydrogen. So remove these highly acidic alpha hydrogens, we can also use weak bases, and such as sodium bicarbonate, sodium carbonate, potassium carbonate, pyridine, etc. So case 3, when both carbonyl groups are esters, then oxybase only used, that is NaOR, okay. So example, this is the example, that is very important structure, that is dimethyl manolate, DEM, DEM. So here used basis is sodium hydroxide, okay, and OET minus. So this is the malonic acid formation, and OET, if there is also present in OET, then dianion of this species is present. So therefore we can't use NaOH, okay. So only NaOR is used for this case. Next, enolate formation of unsymmetrical ketones, okay. So in the next class I will discuss about this.